We left off about here. So here's what I want you to graph now. I want you to graph, what does that say?
Natural log.
Natural log of x, which just means you're in base what?
E.
You're base e. Graph this here, but graph what first?
The parent.
Yeah, go with the parent. Okay, here we go. Go with the parent first. Now, sometimes this is the hardest part. Just what is the parent? And since we're dealing with a log problem, the parent would be log of x. But it's not log, it's what? ln of x. And that's it. Just leave it at that. And it's base what, though? E. So if you can graph that, then you can just take that graph and shift it right, left, up, down, stretch it, whatever. Let's just get that graph. Now, some of you might have a really good memory, and you might already know the 2 points I want you to graph, but some of you might not. And I think a lot of you just don't remember that slide very well that I had about 2-3 slides ago. If you want to make this graph, don't ever make a table with this. Always convert this to what? Exponential. So go like this. E to the what? Equals x. Now these two equations, by definition, this is what logs are right here. This, by definition, this is what it is. This is much easier to graph, by the way. If you made a table, a quick table, what would you put numbers into, x or y?
Y.
Yeah, it says take e, raise it to the y. Put a number in for y. What's a good number?
0.
And there you go. Do it. Put them in, graph it. Give you 30 seconds. E to the 0 is 1. E to the first is
2.7.
E. E to the first is E. I know that's 2.718 dot dot dot. I don't care. It's just E. E to me it's just E. Now move over, graph it. Here we go. 1, 0 here. How do I graph E1? Yeah, move 2.7 over.
Oh, 4.
Up 1. So here's 3. So I would be not quite 3, but close, right? And then, guys, if you don't know where to go from here, just if you wanted, you could just do this, right? This would be e squared. Okay, now there you'd probably want to get, what is e squared, roughly? Type it in.
7.3.
Okay, 7.3?
Yeah.
4 maybe? Okay, so really I move over 4, 5, 6, 7, and a little more up 2. Look. What's going to happen if I keep getting closer and closer to 0 with my x's? It runs into the vertical asymptote. What is the vertical asymptote?
0.
X equals 0. There you go.
Y.
No. Everywhere you look, this is 0, 10, 0, 9, 0, 8, 0. X is always 0. Okay? Now, it runs in and it goes like this. That's it. Good? But that's not the answer. Who is this? It's parent. Okay, yes, please.
How do you know the first?
How do I know? I never did prove it to you, but if I plugged in 1/2 for x, I would probably be here. If I plugged in 1/4 for x, I would be way down here. And I could keep plugging in smaller and smaller numbers. And once I hit 0, there's no answer for 0. So, and then by definition, you can never take the log of a negative number. So all these negative x's, they don't exist. So guys, what's the natural log of negative 5? If I let x be negative 5. Can you take the natural log of negative 5? No. Type it in your calculator. It just doesn't work. And it's by definition. You can only put what numbers in for a log?
Positive.
Positive. And you can't put 0 in, just positives, okay? So basically that's it. Now, tell me what this little piece means.
Up one.
It's so,
Shifted.
yeah, this is so simple. Up 1. Okay, so let's do it. This point goes up 1. Now where am I at? 1, 1. Okay, go up 1. Anybody know what that point is?
2.7, 1, 8, 2, 8.
How far over did I go?
2.7.
Can I just say E?
Yeah.
I went over E, up 2. Okay, so now I'm at E2. Okay, kind of sounds like battleship, right? Here I go, taking off. Now, tell me something about the vertical asymptote. If you take this point and you move it up 2, you're right back to where you were. Okay, so really it's still going to be what? The x equals 0 is your vertical asymptote. Okay, now, here comes the questions though. Look up here. Give me the domain. What x's actually got answers? X is greater than 0. Guys, are you looking at your vertical asymptote? Everything to the right of it for x's got answers. So x is what? Greater than 0. All real numbers greater than 0. Okay, and then next is what? Vertical asymptote is right here. VA. Right there. Okay, next would be the x-intercept. 1, 0. Okay.
No, it's not.
Wait a minute. You went up 1 and it curled. Ooh, it missed 1.
Plug it in.
Plug what in?
I don't know.
He doesn't know. He's kind of right though. What? Which one's 0? If you want the x-intercept, plug 0 in for y, and this is y right there, by the way. So here we go. 0 equals natural log of x plus 1. You gotta solve it. No, don't do that. Not yet. You don't want to do that yet. You want natural log of x all by itself. Subtract 1. Okay. Subtract 1. You end up with the natural log of x equals negative 1. Okay. Then, I'm going to get rid of this. Okay, then, that, you want that x.
It's 1 over e.
See that? That's e. So what I would do is go back to exponential. I would just convert this to exponential because it makes more sense to me. E to the what? E to the negative 1 equals x. So guys, where does it cross the x-axis? 1 over e. Now, Molly, were you going to give me the decimal version?
Yeah.
What is it?
Oh, it's 0.37.
0.37, comma 0. So she's got an approximation, and it's kind of nice to know. I mean, it is inside of 1. It's between 0 and 1, and she says it's this. Because she typed that in. She typed in e to the negative 1. Okay? You okay with that? Those are the hard ones. When they say, what's the x-intercept, and it doesn't hit 2, 0, 3, 0, 4, 0, those are the ones you have to work for. Okay? Questions? Everybody's raising their hand. Okay? All right. Use the one-to-one property to solve these kind of log equations. Well, here's the deal. You already know the one-to-one property. It's just basically whenever the base is the same, so the log of log base A equals log base A. Well, if you have log base A equals log base A, what do you know about these two numbers?
They gotta be the same.
They gotta be the same. So if this is x and this is y, you should know all you have to do is do what? Set them equal to each other and figure it out. When will they be the same? Do you have bases that are the same? 2 and 2. You got base 2 equals base 2. Guys, just ignore the 2 and the logs, everything. This number right here has to be the same as this number. So what are we going to do? We're going to set them equal to each other. There you go. Morgan, do you have an answer? She says 1/2. Is she right?
Yes.
Okay, she's right. Push this over. Plus 3x makes 4x. Push this over. Minus 2 makes 2. Divide by 4. 2 fourths or 1/2. Okay, and can you check this? Sure you can. What's 3? Hey guys, what's 3 times a half? Half of 3.
1.5.
4 take away 1.5. Okay, so you're taking the log of what? 2.5, base 2. This would be 1/2 plus 2. You're taking the log of what? 2.5, base 2. That's it. You got it. It works. So you can check them. All right, do the last one. Base 3, base 3. You've got base 3, the same base. You can do these. These are easy. They should be. Davidson, there's a special spot for you. And this is big, is all I'm saying.
Oh,
All right, what are you guys doing here? Say it. Tell me what to do. Just say what to do. Subtract 4, exactly. I would not waste my time putting everything on this side. Factor, use the quadratic formula. This is the easy one. When there's no x term, just solve for x squared. Square root, the answers are?
minus 5.
Okay, there you go. Pretty simple, right?
I thought we weren't doing the plus thing.
Anytime you solve an equation and you take square root of both sides, it's plus or minus. What do
You
you
did say we weren't doing plus or minus for something. I forget what it was.
Yeah, you
something
did
to
say
be like,
But it's like
no
this.
plus or minus.
Okay.
It makes sense.
If I knew what I was
I'll go
talking,
back.
what you're talking about,
It's like real independence.
Oh.
Yeah.
Oh. can you?
You can tell them when you use it.
Well, you only use it if you're solving equations and you're taking the square root of both sides. That's the only time. If you can find them, Molly, tell me.
Okay.
All right, guys. I think there's one more slide, right?
No, I think that's it.
No, just turn it
Oh,
over.
there it is.
Turn it over. Yes or no? Is it a graphing one? Yeah.
Yeah.
Okay, here's the deal. Students get confused on graphing, so I've got 2 more for you to do. I've already shown you how to do it. Do the top one, number 1, and then just stop. Don't do the bottom one yet. Do the top. Can somebody remind me what it is though?
2 plus 2x minus
2 plus
2 the x minus 2.
x minus. Okay, got you. I suppose equals y. F of x. Okay, which is y? Have you already started with the parent? I would. And that's how I explained it to you. Now you gotta tell me this. Is this a log problem or is this exponential?
Exponential.
2 to the x. It's right there. It's 2 to the x. So that is your parent, right? I keep telling you guys, this is the hard part. Some students just don't even know what the parent is. It's just, it's either gonna be 2 to the x or log of x base 2. And this one's 2 to the x because it's exponential. First get that graph and then let's talk. The next question is going to be, is that exponential growth or decay? Okay, so you kind of know what it looks like, right? It goes like this. Goes like that, right? Okay. quick table, here I go. I only want 2 points. You can give me more if you want, but I just need 2. So where are you going to plug your numbers? In for x or y?
X.
Yeah, it says 2, raise it to the x power. I plug it in for x, so what number?
0,
And?
1.
Yeah, those are the easy ones. 0 goes in, 2 to the 0. 2 to the first, 2. You can get me more if you want. 2 to the second, 4, 2 to the third, 8. I mean, you can do it if you want. But here's the deal. If I just know what the parent looks like, I'm good to go. I know the parent's going to do this. I know it's going to hit 4. I also know it will eventually hit 8. Okay, but what does it do as it goes left? Okay, what? Yes, but it rides on top of the x-axis, which is what? Y equals 0, right? So that's the horizontal asymptote. That's your parent. That's not the graph. Don't call that your answer. Now you got to start thinking, what do I do to the parent? Okay, how many transformations are up there?
2.
Okay, here's the deal. You have to start getting really good at this, and that is what's first and what's second. What do I do first and then second?
Right
What?
2 up 2.
Right to,
Up 2.
what'd you say? What'd you say first? Right to, okay, because this is grouping, isn't it? Okay. Now, is that the correct order? Right to, up to? Somebody's going to say, does it really matter? Not this time, but sometimes it does. Okay, here's the deal. How do I know what to do first and then second and then third? PEMDAS, group, order of operations. Pretend you put a number in, guys. Just pretend. You put 5 in. What would you do first, right now? Would you do 5 plus 2 or 5 minus 2? You do this, wouldn't you? So that's first. And that is right 2. Okay. Then once you do that, of course, you take 2 to a power, but then you add 2 last. Adding 2 is last, so that's up 2. So you do exactly what you wrote down. Start with this point, right 2, up 2, you're right here. Good? Go to this point, right 2, up 2. I did put down 2, 4, just so you know. So if I go right 2, up 2, I'm here. So I can kind of see it. There it goes. But here comes the biggest question of all. Where's the horizontal asymptote?
Y equals 2.
Yeah. Hey guys, if you take this point, just I'm picking a point at random, and you go right 2, I really didn't change much, did I? Up 2, oh, guess what? I'm right above what? Y equals 2 is my new horizontal. So this thing's going to ride on top of y equals 2. Okay? So what controls that horizontal? What kind of movement? Up or down? Does left or right change it?
No.
No. Okay. You got to get that in your head. What changes the asymptote? Okay, there's one more, right? Okay, now here's the deal. Would you do me a favor or do yourself a favor? Call this the y-axis. Call this the x. Okay, now do number 2. Okay, so just slide down. And I need a little help. I don't know what it is. Natural log of what?
Negative X.
Negative x, like this?
Yeah.
Yes.
Inside or
It's in.
Is in parentheses.
then what?
Minus 3.
Equals y or f of x, okay.
GX.
Okay. Parent. Get the parent on paper. What is the parent? Y equals what?
Natural log of e to the x.
Natural log of,
E to the x.
no, well, just x. I mean, you can say e, base e, but I don't have to because it's assumed to be base e. This is the parent, natural log of x. That's it. You get that graph, Then do your transformations and you're done. Okay? Although, if you listened to me yesterday, I said it's not easy to graph log equations. Convert it to what? Exponential. Because if you do that, it gets so much easier. This is base e. What are we going to say? E to the what? E to the y equals what? X. So if you just convert it to what a log really stands for, this is what a log stands for. This is the meaning behind log. Okay? And then make a quick table. 2 points, not much. Help. But just tell me what to put. Where do I put my numbers in? X or Y?
X.
No, not X. Put it in for Y. What number? And this is the weird one. Logarithms are kind of weird because you change to exponential, then you throw numbers in for Y. E to the 0. E to the first. E. There you go. You got it. Go graph them. Where's 1, 0? Right about here. Where's the other one? The other one was what? E1. Where's E1?
2.7. 2.7. 1.
2.7. 1. Okay, and then you know it just climbs, right? And it runs into the what? Runs into the y-axis.
Yes.
Okay. Now, again, this is your vertical asymptote. So there it is. VA. Vertical asymptote. Okay. Now, that's your parent. That is not the answer. The answer comes from the more difficult looking one. This one. So, you got to tell me what to do. First, you do what?
Reflect over the y-axis.
Yeah, this is, they went inside and they changed x to negative x. That's a reflection over what?
Y.
That's reflection over y. Okay, followed by number 2, down 3. Okay. All right, so here we go. We do one at a time. Take that point. Reflect it over y. You're 1 to the right, now you're
1 to the left.
okay, and now you're going to go down 3. Wouldn't you be about right here? Right? Okay. This one, your e to the right. Reflect it. Your e to the left, which is negative 2.7. And then down what?
3.
1, 2, 3. You're about in this, it's hard to see. About here. Okay, think about it, guys. This goes this way. If it's reflected, it's going to go this way, right? Here it goes. Good? Now, when you look at the asymptote, if you reflect the asymptote over the y-axis, aren't you right next to it? On the other side, you're about right here. But now, if you move that down 3, you'd be about here. So really, it's just going to do what? It's going to ride the y-axis on the other side. Okay? I know I did not ask you for this, but please do it anyways, because it's on the quiz. Right now, would you go find the x-intercept? It's about right here, somewhere in that area. Go find it. If you can find it, you're pretty good. This is not easy. And don't use your calculator. Like, what I mean is, don't graph it and use your calculator to find it. Don't do that. That's cheating. Wasn't this it, by the way? Okay. And you guys know when you look for the x-intercept that y is 0, right? So f of x, I hope you did this, cross it out and just put 0 there, right? Okay, tell me what to do. Yeah, solve for ln of x. Add 3, and get what? 3 equals natural log of.
Negative x.
That's the number you're taking the natural log of. You can't do anything to that number inside. Whatever you're taking the log of, you can't do anything to it. So you're practically done right now. But what's x?
Negative 3.
Ready? Convert e to the what? E to the third equals, what's that number in there? Negative x, right? Okay, hang on a moment. I'm just about there.
Divided by negative 1.
Divide by what?
Negative 1.
Negative 1. Okay, so x equals negative e to the third is what it is. Would you type that in for me, please? What's negative e to the
20.1.
Say again?
Negative 20.
Negative 20.1. So if I go back to my graph, which, it's back here, I guess. No, that's not it, is it? It's down here. Okay, so here's the deal, guys. I know my graph doesn't do it very well, but it goes like this, this, and by the time it actually hits the x-axis, it's what? We're already at negative 20.1. Good? I think that's it. You know what I forgot to do with you, though? I don't think I did the last slide on day 1. 3.1, did I? No. We got to talk about it because I don't want you to get this wrong on the quiz. I got to show you something. If you look at the whiteboard, I did something for all you guys, all pre-calculus kids. Watch this. There's exponential growth. Then there's exponential growth with money. Then there's exponential growth if it's continuous growth. You never use this formula here unless you hear what? The word continuous. This is known as the PERT formula. P times E to the RT. Okay. If they don't use the word continuous, then you go right here. This is growth. P times 1 plus R to the T. Once they start talking money, though, this 1 plus R gets kind of manipulated. It's 1 plus R over what? Do you even know what N stands for?
Isn't it amount of time gets compounded?
Number of times per year your money gets compounded. If I'm a banker and I tell you I'll pay you quarterly,
4 times.
I'm paying you 4 times a year. This would be a 4. This would be a 4. If I tell you I'm paying you monthly,
12.
12, okay? But this only applies to money problems, okay? This is just exponential growth problems. This is continuous growth. What's this?
Decay.
This is decay. This is the last slide in day 3.1. Go there. We're going to use the decay formula. And notice decay is 1 what? Minus. Okay. Would you please right now go do that last slide? I will catch up with you. It is the last slide on day 1. We didn't do it. It's this one right here. All right. Read it. There's 2 questions, by the way. That's your first question. And that's your second question. How do you know this is decay, by the way?
It's depreciating.
The word depreciate means you're going to lose money. Okay, so if you guys have already bought your first car, if you're already driving your car and you bought it, every day you drive your car, your car what? Depreciate. It means you lose value every day because you're wearing your car out. Okay, so each year a vehicle depreciates to what? 80% of the previous value. So 1 year later, today it's worth 100%. 1 year from now, it's worth what?
80.
80. But is that the R in our formula?
No. No, it's 0.2.
Yeah, see, it's still worth 80. You actually lost what?
0.2.
You lost 20% or better yet, 0.2. Okay, you lost 0.2 or you lost 20%. So the formula becomes this. To get the value of your car, that would be A, the final amount is equal to what you invested. How much did you buy your car for? Don't say 20,000. Just say what? P. The original amount you paid times 1 minus your decay rate. 0.2 for how many years? T. This is a formula. It's not you really doing the problem. Okay, that's the answer on the quiz. But you can simplify this answer. P times 0.8. 1 take away 0.2 is 0.8 equals A. There you go. That's the formula I'm looking for. When I say write a model, this model will get you any answer any year. Okay, then the second question comes, how much is a vehicle worth 20,000 today worth 5 years from now? What goes in for P?
20,000.
20,000. After you subtract the 20%, you're down to 80%. For how many years? 5. 6,000, what was it?
553.
553 and something.
60 cents.
60 cents equals A. A is the final amount, what it's worth. Sorry about this. Yep. So, you bought a $20,000 car, 5 years from now, you just lost how much money? $13,500. But if you paid it off, guess what? Your car's still worth what? $6,500. So you still have, your car's worth money. You paid it off, you have no more payments, and now you have a $6,000 car. You lost a lot, but you have no payments, you're good to go. Okay? Who's bought a car already? Bought a car, not mom and dad gave you.
I bought the car,
You bought the car?
the Honda Civic.
Good job. Buy one?
Yeah. 05 Nissan Maxima.
Ooh.
When did you buy it?
Huh?
When did you buy it?
I bought it 2004. March of 2016, I think.
Okay, so his car's 10 years old. So you know what he did? He bought a car. That car's probably worth almost $20,000 in its day, but he bought it down here. So it's not worth much. So he's not gonna lose. He's not gonna lose much money. If it's not worth much now, a couple years from now, Paul, you're not gonna lose much money. The person who loses most money is the person that buys it what? Brand new. Brand new, you lose a lot of money. You just do. So my advice to you guys, being your high school kids, buy a car older than what? Older than 5 years. Older. Like 6, 7, 8, 9, 10. He bought a 10. Good job. Hopefully it still runs.
Oh, yeah.
The 98 Honda Civic.
Okay. That's it, guys. Did I already give you the assignment?
Yeah.
Yeah.
Years old.
Go on.
Maybe.